Hello friends, so welcome to Kranti Physics Tutorials. So today we have to discuss about the series and parallel combination of the capacitors. Okay, then we have to discuss about series and parallel combination of the capacitor. So what we have to discuss about, so how we connect the capacitors in parallel and how we connect the capacitors in series, and finally, so what is the equivalent capacitance equation we have to get. So that equivalent capacitance we will derive in this question. Okay, so here first so we connect the capacitors in series. We connect the capacitors in series. So here so the capacitor symbol already we know that. So the capacitor symbol is this one. So this is the capacitor symbol. So here the two lines we can draw, the two lines are same lines. So same length lines we have to draw here. So this represents the capacitor symbol. So here we connect the capacitors in series. So look at the board how I can connect the capacitors in series. So we can connect the capacitor in series, so like this. So this is the capacitor C1, C2, C3. So here for example I can connect the three capacitors, and the three capacitors having C1, first capacitor having C1 capacitance, second one having C2, third one have C3 capacitance. So all these three capacitance are connected in series like this. Now this total combination is connected to a battery. This total combination is connected to a battery. So here battery provides the potential difference. So here whenever the potential difference is developed by the battery, so then the current is flowing like this, and so whatever the current is, how much current is entering into the first capacitor, so the total current must and should be passing through all the capacitors. Why? Because there is no another way to split the current. So that's why the total current is passing. So same current is passing through all the capacitors. So same current is passing, then same current is passing, so then all the capacitors are having same charge. Why? Because same current is passing through all the capacitor, so all the capacitors are loading by similar charge, same charge. So that's why in series combination you must and should remember charge is same on all the plates of the capacitor. So here in series combination, so charge is same. You must and should remember this point. So here this is having charge Q, this is also having charge Q, and this is also have charging Q, same charge. That's why I can't write here Q1, Q2, Q3. So all the charges are right like same Qs. Why? Because all the capacitors are having same charge. But here the capacitances are different, and also the potential is also different for all the capacitors. So potential, so V1, V2, V3. So potential difference of the each capacitor is different. Capacitance of the each capacitor is also different, but the charge of each capacitor is same. Okay, so why? Because the same current is passing through all the capacitors. So here charge is same, but V equal to, but potential V equal to, so V1 plus V2 plus V. So Q is same, but potential is different. That's why the total potential V equal to V1, first capacitor's potential, second capacitor's potential, and third capacitor's potential here. So V equal to V1 plus V2 plus V3 here. So therefore, but already so we knew the very important relation. So that is Q equal to CV. So the relation between the charge, capacitance and potential is what? Which one? Q equal to CV. So this is the very important relation. So from this relation, so we can write V equal to Q by C. From this equation we can write V equal to Q by C. So V1 equal to Q by C1, V2 equal to Q by C2, V3 equal to Q by C3. V2 equal to Q by C3. So from Q equal to CV equation, so we can write that equation. So then, so all these values are substituted in this equation, in above equation. So all these values are substituted in this above equation. So what we get? So Q by C equal to Q by C1 plus Q by C2 plus Q by C3. Q by C3. So why here we write only Q's? Why? Because the charge is same on the each plate of the capacitor. Okay, that's why we can write only Q, not Q1, Q2, Q3. Okay, so here so we take Q by C is equal to, so here we can take Q as common, right? So here we can take Q as common. Then what we get? 1 by C1 plus 1 by C2 plus 1 by C3. So Q are cancelled, get cancelled. So finally what we get? So 1 by C equal to 1 by C1 plus 1 by C2 plus, so 1 by C3. So this is the equation for equivalent. This is the equation for equivalent capacitance of the capacitors are arranged in series. Okay, so 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. So if you can connect the fourth capacitor, then what we get? Plus 1 by C4. If you can connect the fifth capacitor, so then what we get? How we can write the equation? So plus 1 by C5. So like this, so on. So how many capacitors are you can connect it? So here we get that much of C1, C2, C3, C4 are here. So this is the equivalent capacitance equation for the capacitors are arranged in series. Now we will go to the capacitors are arranged in parallel. Then so which equation, which equivalent equation we get? Now we will derive. Okay, so the capacitors are arranged in parallel. So parallel combination of the capacitors. So okay, so here also I can take only 3 capacitors. So these 3 capacitors are the combination of these 3 capacitors are connected to a battery terminal. So we can draw the parallel combination of the capacitors like this. So here parallelly, so all the first plates of the capacitor, initial plates of the capacitor are connected to the positive terminal of the battery, and so all the second plates of the capacitors are connected to the negative terminal of the battery. So in this way we can connect the parallel combination of the capacitor. So here every capacitor has so C1, C2, C3. So each capacitor has different capacitances C1, C2, C3, and the each capacitor also, so each capacitor has different charges also, Q1, Q2, yeah, Q3. So every capacitor has different capacitances C1, C2, C3, and every capacitor has also different charges Q1, Q2, Q3. So but here which quantity is same, similar for all capacitor? So the potential. So potential V is same for all. So V is same for all. So but in the series combination, which one is same? Charge is same. Charge is same on each plate. But for parallel combination, which quantity is same? Potential is same for all the capacitors. Why? Because all the first plates are connected to positive terminal, all the second plates are connected to negative terminal of the battery. So that's why the battery provides similar same potential to all the capacitors here. So here V is same for all. So but Q is not same for all. So that's why so we can write, so Q equal to but Q equal to Q1 plus Q2 plus Q3. So here we can write Q equal to Q1 plus Q2 plus Q3. Why? Because Q is different for each capacitor. So but the same equation, from which equation? But Q equal to CV relation. So so from Q equal to CV, what we can write? How we can write? So Q1 equal to so C1V, and Q2 equal to C2V, and Q3 equal to C3V. So what we can write here? Q1 equal to, from the equation Q equal to CV, so we can write Q1 equal to C1V, Q2 equal to C2V, Q3 equal to C3V. So but here V's are, so we cannot write as a V1, V2, V3. Why? Because V's potential difference is same for all the capacitor. So that's why we can write only C1V, C2V, C3V. So now all these are values are substitute in the above equation, Q equal to Q1 plus Q2 plus Q3. So then what we get? So therefore Q equal to Q1 plus Q2 plus Q3. So we can substitute all these equations. So CV equal to C1V plus C2V plus C3V. So from this we can take V as the common. So V equal V into C1 plus C2 plus C3. So V cancel. Therefore C equivalent. So equivalent capacitance equal to C1 plus C2 plus C3. So this equation we get finally. The equivalent capacitance for the parallel combination of the capacitor. So what we get? So C equivalent is equal to, so C1 plus C2 plus C3. So you can, so here I can connect only 3 capacitors. So that's why I can write C1 plus C2 plus C3. You can connect. So number of capacitors are arranged like this. So here, so what we get finally? The equivalent capacitance, C equivalent capacitance of the parallel combination of the capacitors are, so C1 plus C2 plus C3 here. So why? Because here only 3 capacitors are connected. That's why we get C1 plus C2 plus C3. If you connect here C4, fourth capacitor, then we will get C4 here. So if you can connect fifth capacitor also, then we will get C5 here, and so on. So this is about so series and parallel combination of the capacitors arranged. Okay, everybody, is it clear? It is very simple. Okay, it is very simple. So this is Kranti. So signing off. Thank you.